I had to eat my words a little bit when it comes to this spherical Tokamak fusion device. I briefly believed that the UK Atomic Energy Agency had purloined my idea, which they didn't do that. No, they didn't. The spherical Tokamaks have been around for several years. I think it's not really a new idea as such. I believed it was a new idea. I thought that no such Tokamak device had really ever been designed or conceived of before, and that mostly it was like magnetic confinement or inertial confinement fusion. The two ideas hadn't been sort of squeezed together into the spherical Tokamak compromise, because I did what you should never do, little knowledge being a dangerous thing, doing a bit of Googling around, trying to find all the different sorts of fusion reactor and not coming across spherical Tokamaks. So that was a blunder, a mistake, which I occasionally am guilty of doing. Which can happen. But yeah, still, right, so still, I don't see spherical tokamaks working on the planet still. That's the bottom line of this video, and I think any and all Earth-based fusion research is not the direction we need to be pursuing with nuclear fusion. That's somewhat my inclination. That's what I'm inclined to think. That's what I'm inclined to believe about nuclear fusion research. As I mentioned in other videos, I think we've got more than enough in terms of options for ways of powering our society, and not merely powering the society that we have at the moment and sustaining that, but greatly increasing our productivity, very possibly, if we learn how to harness the energy, the huge amounts of energy present on planet Earth, and gradually reducing our dependence on fossil fuels. And we need to incorporate agriculture into this. We need to be starting to grow more energy crops, principally hemp, I'd have said. Cannabis sativa L, the hemp plants. But really we need to be growing both, big fields of, frankly, the female plant as well. Just cannabis, just big arable fields full of cannabis, using contemporary agricultural techniques, planting and with machinery, mechanical harvesting, and so on, and all these things apply to hemp farming, which we know how to do. We know how to do all that now, and we could really be looking at the dawning of a new age in terms of our outputs in agriculture for fuel crops, and really a dawning of a new age in terms of our capabilities at producing fuel. So the agriculture, the hemp crops element of this thing would need to encompass fuel oils for logistics. So we need to be getting all of our biofuel and petroleum from hemp. We could add other things into the mix to ease the burden on infrastructure, such as I don't know why we're doing electric cars, really. I think there's a bit of a misstep on the part of Elon Musk to get into Tesla, as opposed to pursuing hydrogen fuel cell technology. I think hydrogen is really the big thing we need to be looking at in terms of powering vehicles and powering aircraft as well, burning hydrogen and oxygen in jet engines, and scramjets and ramjets to achieve very high speeds for passenger flight. I'd like to see that also. And yet we're stuck in a sort of a dinosaur age. Pun was intentional. We're stuck in a sort of dinosaur age where we're, living off dead dinosaurs, and we have an abundance of things out there that are sources of power that we can be using. I've been talking about big tidal barrages in the English Channel and the Irish Sea. Those are good ideas, I think. I think we can do that. Looking at some of the things the Chinese have been doing, with their south-north water transport system and their three gorges down, these big Chinese mega projects. I don't see why, Europe, like the largest, most powerful single economy on the planet, I don't know why we should be shying away from those sorts of projects. I don't. I think we can not only do those, we can do them better than they can. We can do better than the Chinese can. You know, and when it comes to the English Channel and harnessing that for tidal energy, and not thinking about so much the length of the tidal barriers, but the width of them. What would any amount of turbines, harnessing all that current from the Atlantic Ocean, what's it going to do? Is it going to slow the current of the Atlantic Ocean? I don't think so. Somehow, like, if, not the time, well, an expert on oceanography or ocean currents or anything like this, but I just see that as being an enormous supply of power. Maybe that could even supply the whole of Europe with electricity, if we get it right. I think it could, maybe. Judging by, what the seven estuary proposal was thought to, be able to attain in terms of energy output. About 8,600 megawatts, I think, was its capacity. These things across the channel, would see that sort of thing pale into insignificance. Yeah, this be in any case, it would be a big, big, big boon to our energy supply, to our supplies of renewables. It would need maintenance, sure. I think it could be maintained, yeah. And like most tidal barriers, and hydroelectric stations with relative ease, not like a nuclear power station where you need to staff all the time with lots of engineers. You don't need that really so much in tidal and hydroelectric. That's a great thing. That's a great benefit of hydroelectric and tidal, because that cuts down on cost, makes it more efficient. We should be doing that sort of thing. And then there's living space, there's infrastructure added into those sorts of considerations also. But yeah, in terms of doing fusion now, we need to get into space and do it. That's the thing. So we must be building rockets that are quite a bit bigger than the largest rockets we have at the moment. If you want to launch a fusion reactor into space, I'm afraid an Ariane 5 isn't quite going to cut it. Nor really is an SLS. Or a space shuttle, or anything like what we've been using in the past. We need much bigger rockets. We need a rocket, I'd have said about 1.5 times the size of the SLS, at the minimum. I'd see that take off. 1.7, 1.8 times the size of it, I think that's more like it. To get smaller fusion devices into space. And, then to start, because the major problem I think with fusion is the reactors will wear out, and then there's an energy input there, a big energy input involved in building them in the first place. Or they'll wear out. They're exposed to, there's too much temperature there. You're trying to contain too high a temperature, and the manufacture of all those parts costs a huge amount of energy. If you analyze its footprint in terms of production, and obviously enormous costs as well associated with it. And fusion, in the sort of the 50 years or so that fusion research has been going on, it hasn't really gotten cheaper at all, which is a troubling thing, I think. But yeah, needs to get small scale to begin with fusion devices in space which utilize the cold background of space. These temperatures of sort of minus 220 degrees centigrade or so, to cool those reactions. And then maybe something like a Dyson sphere surrounding it to harness more energy. Maybe we can even manipulate the emitted energy with things like lenses and mirrors to get it to where we want to go to. Perhaps we can do that. And yeah, it sort of depends what we really want fusion to be able to do, I think. And yeah, the research venue for this sort of thing is in space, I just said. And new stars in the sky, very possibly. Lovely stuff, I think. That would be. So thank you for watching. Please share this, like, subscribe, etc. I'll be putting out more videos about the ideas I've been coming up with in due course, and I will see you soon, hopefully. And yeah, like if in your private life you could sort of talk to people about these ideas and like try and generate interest. You know, I think sort of we're bound into this myth of insurmountable problems in the world, and you know, the more we talk about it, the more we share ideas, the more we raise awareness of you know, the real solutions to these things that exist out there, the better I think we can do in this sort of thing, and we can start making good, solid progress quickly and faster, and no more waiting 50 years for fusion. And you know, fusion's 50 years away and always will be. Or maybe that'll be true. Like if we're doing it sort of at light speed, you know, 50 years away and always will be.